Welcome everybody. My name is Sébastien Deleuze. I work at Pivotal as a Spring Framework committer, and today we are going to talk about Spring Boot, but we are trying to see how we can build Spring Boot application in a different way than usual. So instead of using Spring Boot Java annotations, we are going to see how far we can go with Kotlin, Kofu, and Coroutines. If you don't know what is Kofu or what is Coroutines, we will talk about that. That's the topic of the talk. But before going deep into the various technologies, I would like to talk about my goals in that work. The first goal is to improve the code signal-to-noise ratio, to make features more discoverable, to make reactive easier. We all know that reactive programming is very interesting in terms of scalability, stream processing, back pressure, but it's not a free lunch, so maybe we can find ways to make that easier. I think that in code, it's like in life, explicit behavior equals less misunderstanding. So we will try to see how that applies to Spring Boot configuration. And I truly think that efficiency, especially runtime efficiency, is really a key topic, especially when it comes to run your application in the cloud. That said, the context is that the Kotlin rise continues. We have announced the official Kotlin support in Spring in January 2017. That was quite early, I think, quite an early bet. It was before Google announcement about official support of Kotlin in Android. And obviously, the big increase of Kotlin developers mainly come from the mobile world, so there is more and more Kotlin developers that are coming to Android. I think they expect 4 million of Android Kotlin developers at the end of the year. But this big amount of Kotlin developers also impacts server side, and I think we are going to see more and more usage of Kotlin on server side, and I try to make that first-class support on Spring side. So today we are going to see 4 steps to go from a typical Spring Boot application in Java to an idiomatic Kotlin one. So my message is not you have to reach the step 4 to be step 4 is not necessarily better than step 3 or step 2, but I want to show you a progressive and gradual migration from a typical Spring Boot application in Java to what is maybe the future of a typical Spring Boot application with Kotlin. And we are going to start by the step 1. We are going to see how look like a Spring Boot typical application in Kotlin. And to do that, I will show you a simplified version of the application that I have developed for the official Kotlin tutorial on Spring. That you can find on spring.io. You go to guides, you type Kotlin, and you will find this tutorial that will explain you basically all you need to know to develop a Spring Boot application with Kotlin. So let's see that in terms of code. So this is a regular Spring Boot application. Maybe one of the differences here is that I have manually migrated the Gradle build to Kotlin DSL, because like Spring and Google, Gradle announced Kotlin support. So now, starting Gradle 5, you can write your Gradle build with Kotlin DSL, which is an alternative to the Groovy one you already know. And one of the main interest of that is that the Kotlin DSL is more statically typed, so the IDE will provide you more guidance. Usually with the Groovy version, you mainly copy and paste code from internet and you try to make it work in your project. At least that's what I did. Here, the Kotlin DSL provides more guidance to Gradle model, which is sometimes a little bit disturbing. So I think that's a good fit. This is not yet supported in start.spring.io, but it should be shortly. So you will maybe able to use that shortly. So let's have a look to our entity class. So the first thing to notice is that it is short. So you may think, okay, but I can do that with Lombok and Java. But I think there is much more here. The first thing to notice is that you can use this kind of short syntax that is also present in Scala to declare at the same times the the constructor parameters and the properties. So you declare that with this kind of syntax. Here we are using var properties because we are using GPA, and GPA is not designed for immutable data classes. So we try to stick with what GPA is awaiting here. The type are suffixed, and an important thing is that the type in Kotlin are null safe. Null safety is managed. That means that string is not nullable, but long with a question mark is nullable. Okay, so that means that the null safety will be checked at compile time instead of runtime, and you will have to fix that as a developer when you develop your application, instead of having to deal with runtime with the null pointer exception at runtime. Another interesting feature is that we have optional parameters with default values, like slug, for example. So if the end user, if on the usage side we don't specify the slug parameter, it will automatically take the title to slug value, same for added at and same for the ID. And that avoid to specify multiple overloaded versions of the constructor. Here the goal is to improve the readability and the maintainability of your code. And the last point I would like to mention is that you see this kind of, this is a little bit strange for a Java developer. I'm coding toSlug, which is obviously a customized method, on title, which is of type string. This is done via extension functions. So Kotlin allows you to add some additional methods to existing types. So here I'm transforming a string that can contain spaces and special characters to something that will be usable in the URL. And I am adding that to the string type. And the important point is that it's not magical. You have to, here I am in the same package, so that I can show you that, but you have to import these extensions to be able to use them when they are not in the same package. So it's not global scope and magic, it's really you have to import them like you import static imports, for example. And that's the equivalent in Kotlin world of abstract classes with static methods, but in a much more readable way, I think. On controller side, we are keeping the same model you are likely used to use. We favor constructor-based injection even more in Kotlin than in Java. So here there is a single constructor. So the @AutoWired is implied, and it will be automatically injected by type when the bin will be created. I am using a short syntax because the body of the method is one line, so I'm using this short syntax. And here you can see that we are leveraging Kotlin type inference. So a very important point is that Kotlin is as statically typed as Java, and even more with the null safety thing. So here, even if I don't specify the type, here it's just an int displayed by the IDE. I have not specified it explicitly. The type of find all will be inferred by the type of find all by order by added at desk. Okay, so everything is statically typed, and you can obviously specify the return type if you prefer it, but you can just display the int like I did. The repository is barely the same than in Java, okay, except that here, instead of using optional of article, I'm using a new label of article. That's also interesting because you don't have to pay the cost of a wrapper to do that. In terms of readability, that's better. And also, new label values can be used as parameter, while with optional, it's not recommended. On the application side, you have this top-level run application function which is provided with Spring Boot, and it's not just syntaxic sugar. You can also add a lambda to customize various parameters of your Spring application here. And as of Spring Boot 2.2, thanks to the great work of Stefan Nicol and the Spring Boot team, you can now use immutable data classes for your configuration properties, and that's a very good fit because really typically configuration properties are immutable, and it's very nice to be able to finally use this kind of Kotlin idiomatic syntax to define them. Okay, so now we have seen basically what look like a typical Spring Boot GPA application with Kotlin, and we are going to continue to continue the work by switching to step 2. So in the step 2, I will migrate from a blocking stack, and blocking is not an issue. I mean, we all use Spring MVC, GPA for years, and that's perfectly fine for a lot of use cases. But let's say we need more scalability. We need to request some remote web services that are slow, involve latency. I want to do more stream processing, and that I want to leverage the new reactive stack that has been introduced with Spring Framework 5. So we are going to switch from Spring MVC, which I called Web MVC here, with GPA to WebFlux and R2DBC. So WebFlux is basically the new reactive web framework that is similar to Web MVC, but in reactive world. Okay, it supports the same kind of ad controller programming model. And R2DBC is a new thing that I would like to introduce today. R2DBC is not tied to Spring. It is reactive SQL SPI, low level, basically like a reactor. So it can be usable outside of Spring. It only depends on reactive streams, and most of the drivers that we have implemented are based on Reactor Native, and another one is based on JSync. This is a MySQL one. So we have support for PostgreSQL, MySQL, H2, and SQL Server from Microsoft. This is not production ready yet, but we are working hard on that. And the idea is to provide basically a reactive equivalent of JDBC. And there is this ADBA effort from Oracle, but it's asynchronous, but not fully reactive. That's why we have started this effort on R2DBC, and we try to move forward in a pragmatic way. So in Spring World, you will typically consume R2DBC with Spring Data R2DBC, which is conceptually close to Spring Data JDBC. So if you are familiar with Spring Data GPA, here we are not talking about a full-blown ORM. It's a lower level. You directly write your SQL request, leveraging all the native capabilities of your database. Okay, like PostgreSQL have plenty of very useful native features. And yeah, so R2DBC is basically a reactive version of what we provide with Spring Data JDBC. And it provides two main APIs. One is the usual query, the usual repository pattern that you know if you have used Spring Data. And it introduced a new functional API, which is database client, which is basically the equivalent of web client, but applied to the database world. This is still work in progress, but it's progressing fast. So we are going to see what that means in terms of code. So back in the code. So I'm going to switch to the reactive branch, which is basically the same application, but here we are still using Kotlin, but we are using Spring Data R2DBC instead of Spring Data GPA, and we are using WebFlux instead of WebMVC. So what we can see here is that our article is now a data class. So data is a keyword that will add equals hashcode and make sure that this class only contains data. We are using immutable properties because here we don't have the constraint to use GPA, which forced to use mutable data classes. So here we can use val, which is idiomatic in Kotlin. If we have a look to our article repository, you see this database client. This is the functional API provided by Spring Data R2DBC. And it allows you to write your SQL request directly writing SQL code. You have binding of parameters. You have obviously that translates the result of the request to your object. So it tries to find the right balance to provide you good facilities like that, but not as high level as GPA. And in terms of types return, you see that it returned mono and flux. Okay, so we have clearly here an API to deal with the database, and it returns reactive types mono and flux. So when you retrieve a lot of rows from your database, basically you will get a stream of results. You don't have to load everything in memory and then process them. The flux that returns the articles will go through as they arrive from the database. And obviously mono is just asynchronous, so you can send a lot of concurrent requests. Be aware that's declarative API, so when you have to do sequential operation, you have to use this kind of operators like then to chain operations. If you have used a ReactiveX pattern, you may be familiar to this kind of thing. And that's it. So we are going to modify this example to add, let's say we have a customer that provides a very slow web service. I have faced to this use case many times in my former company. You don't have control on this slow web service and you want to request it to, for example, get the list of the comments. Because here we can show you the application. It is pretty ugly because I'm not a designer, but basically this is a basic blog post, okay? Okay, so we have blog post and then I see the details. And let's say that here I want to add some comments that come from a remote web service and I don't have control on this web service. So I'm going to add it locally for the purpose of this demo. So I'm going to add a command data class. I'm going to add a command controller. So here you can see that we are using Reactor API to provide the list of the commands, and we introduce artificially some latency, okay, just for the purpose of the demo. And I'm going to add the extensions. So here is a good example. Extensions need to be imported manually. And here we are going to modify, we are going to modify our HTML controller to request this remote web service. So I'm going to introduce a client builder, which is a web client.builder. Okay, I'm going to create the web client based using the builder. I'm going to add here, so render article is the POJO that will be rendered on Moustache side, which is a logicless template system. So I'm adding a list of comments. Okay, and then I'm going to replace this render function that is currently synchronous. We just format some data by by a reactive render 1. So let me just import. Okay, that's okay. So here you see that now this function returns a mono of render article because it is asynchronous. So in order to be able to handle that, I will transform the map into a flat map. And I will also perform a flat map operation here. Notice that in Kotlin, I don't have to specify the name of the lambda parameter if there is a single one. So it is the default name of the lambda parameter. Okay, and I'm going to update my template to add basically the list of the comments that I have retrieved here. So if I run my application, okay, now I see the list of the comments that are retrieved remotely. So this was the reactive version, and now we are going to step 3. We are going to switch from ReactiveX. So ReactiveX is the style of API that follow Reactor and Eric Java to Coroutines. So Coroutines are Kotlin lightweight threads that are allowing to write non-blocking code in an imperative way. So while you can't create too much threads because that will cost some CPU and memory, you can create how many coroutines you want. And coroutines are also a way to do asynchronous programming, but in a more imperative way. So to give you a more concrete sense of that, I have written this kind of translation between a reactor and coroutines world. So when you have an handler that returns a mono of void, in coroutine world that will translate to a suspending function that returns nothing. So you can see that we are quite close of the regular imperative world that we know all. You just add this suspend keyword. That means that the return can imply some slow computation, some latency, etc. Handler function that returns a mono of t will be translated to a suspending function that returns t or nullable of t, depending on if you want to allow empty value or not. Okay. Flux translate to mono. We will talk more about mono in the next slide. If you have a method that takes a mono parameter, it will translate to just a plain value because you will call a suspending function to get this result. If you don't need laziness, or if you need laziness, you can use supplier that take a suspending function as parameter because suspending function can also apply to lambdas, and that's an interesting pattern to get some kind of laziness. And again, flux translate to flow when it is used as a parameter. So last year, Kotlin team announced that coroutines were final, and I was disagreeing about that because they were only providing suspending functions, but flow was really missing. I really don't like the channel API from coroutines. I much prefer flow, and that's a much better fit with all the reactive streams ecosystem that we have on Spring and on the GVM. So basically, with coroutine 1.3, I think that's when flow will be final. Currently, flow is still experimental, but it will be quickly final. I really consider that coroutines are finished now. And flow is very interesting because it provides a smooth migration path from Flux. It's suitable for hot and cold stream. So hot streams are basically you are listening tweets that are coming. So you subscribe to a hot source and then you cancel the subscription. Cold stream are more like what I showed you for the returning the rows of a database. You're returning, for example, 100 results, and you want to process them as a stream rather than as a big collection that you put in memory. It's suitable for finite or infinite number of elements. It supports back pressure, but in a different way. So it supports back pressure via suspending functions. So basically, when a function is suspended inside of a flow, it will not request more data, request n data like in reactive streams. So this is how they achieve back pressure. This is a little bit less powerful than true reactive streams, but that's, I think, perfectly fine for most of the use cases. Operators are implemented as extensions, so the flow type has a single collect method, and every operator is implemented as an extension. And I think that's pretty clever because that makes flow really extensible, and the built-in operators are exactly the same that your custom ones. They are just extensions. Operators are easy to implement. Filter, for example, is just 2 lines of code. Some operators are more complex, but most are pretty simple. And for example, it has some interesting characteristics, like map operator support asynchronous operation because the parameter of the map operator is a suspending function. So it's a little bit like flat map, but you don't need flat map. I will show you that later with a concrete example. And it's now. So we are going to go back to the codes, and we are going to check out the third branch, which is the very same application but developed with coroutines. So here we are just adding the coroutines dependencies. We are using Spring Boot 2.2 build snapshots. Yes, I do live coding with snapshots, hopefully in offline mode. And that means that we are using Spring Framework 5.2, which provides built-in support for coroutines. Okay, so the version Spring Boot 2.2 that will be released in a few weeks will support officially in a production-ready mode coroutines. So article is exactly the same. Let's start by that one. So here, the strategy in the Coroutines support I have implemented in Spring Framework is I did not want it to add some wrapper type like coroutine database client, coroutine server response, etc. So the strategy I used is to leverage all the reactive types. So basically the idea is that everywhere you have reactive APIs, you have coroutine extensions. Okay, and here you see that the fetch spec that we were using in the previous version, we provide in the Spring Data 2DBC and Spring Framework jars extensions that extend the reactive types to provide you coroutine-based extensions that are by convention prefixed by await or flow, and that allow me to have suspending function in my repository that return just a plain article or a flow of article if I return multiple results. And that play nicely with support that we have also on the annotated controller side. So I have added support to Spring WebFlux. Be careful, not Spring MVC, Spring WebFlux. So if you want to use coroutine, you have to use reactive stack. And that means that you can use suspending function handler methods in your reactive controller, and you can also use handler methods that return flow. Okay. So basically, from a Spring perspective, it's just another reactive library because we also support interoperability with Eric Java and others. But here, it's a little bit special because we leverage some feature from the Kotlin language. But internally, we are just adapting from reactive streams to coroutines. And we are going to do the same little exercise. So we are going to add a command class. We are going to add a command controller. So here you see we are using a flow builder, okay? And inside the flow builder, when I say that coroutines are more imperative, I'm just using, so this delay is an operator, okay? It's an operator, and you see the implementation is really simple. That's not a lie. I'm calling delay, which is a suspending function identified by this little arrow. Then I call emit to emit a new element. That's flow is pushed base, so we push a new element. Then delay, then emit, but in a more imperative way. And we are going to leverage that in our controller. So I'm going to add the very same web client builder, because like I said, the strategy we had was to add coroutines extension on top of regular reactive types. I'm going to add the command here. And I'm going to replace this render synchronous function by a coroutine one. So let me just import a few. So here you see the extension need to be imported like static imports basically. And when they are imported, you see here this little arrow, I'm getting a client response commands, but in an imperative way. And now my article.render extension is a suspending function that returns a render article. And the interesting thing is that here I don't have to modify my code because a map operator take a suspending function as parameter. Okay. And here, for this version, it is just a suspending call that is used in an imperative way. So I don't have to do any kind of modification here. Going to add templates, and then it should be. I'm going to check with test, but it should be fine. Oops. Okay. Okay, so, going pretty fast. Okay. Now we are going to talk about the step number 4. It's switching from auto-configuration to Kofu. So the step 1 to step 3, we are on something which is production ready, at least when Spring Boot 2.2 will be released and Spring Data R2DBC will be GA, but we are something that will be short-term production ready. Here, I clearly want to draw the line. We are talking about experimental stuff, but I think that's interesting to show you that because that really show that in Kotlin we can maybe do different things, so leverage the very same Spring infrastructure, the application context, the beans, etc., but in a different way, in a more functional way, in a more explicit way. So that's why I want to show you. And I would like to talk about Spring Foo and Kofu. So Spring Foo is an incubator that I have created a few months ago to mature experimental features before their inclusion, or not, in top-level Spring projects like Spring Framework, Spring Boot, Spring Data. So for example, the Coroutines support I have shown you just before, it was previously an incubating feature in Spring Foo that have been graduated to Spring Framework, Spring Data, etc. And currently, Spring Foo contains a single feature, but the biggest, which is Kofu. So Kofu is a minimalist, efficient, and explicit configuration model for Spring Boot using a Kotlin DSL. So basically, it provides a way to configure Spring Boot, not with the auto-configuration that will trigger a feature when something is on the class path, for example, but because that is really the model that perfectly fits for Java, because Java will be too verbose for explicit configuration. But with Kotlin, I tend to think we have a way to specify the configuration explicitly without any real drawbacks. So why not doing that? And I'm going to show you how to do that by migrating this application. So this time I will just stay on this application and I will gradually migrate it to a Spring Boot application with Kofu configuration. The first thing to do is to add the dependency, because Kofu is ultimately just a dependency, which is currently in an incubator, but that's just an additional dependency that will provide you a new API. So when you have imported that, so here we are using a regular add Spring Boot application. We are going to remove that, we are going to remove that, and we are going to create an application using a DSL. Okay, so DSL are a way that Kotlin provides to specify, describe your API in a more declarative way. So here I'm declaring an application that could have various types. So you can use a standalone application, a servlet one if you are using Spring MVC, or a reactive one. Notice that it is just a regular Spring Boot type. You may not be aware of that if you have not used Spring Boot's programmatic API, but that's just plain Spring Boot class. And the interesting thing, remember at the beginning I was talking about discoverability, and I really, what I really would like is to expose all the features from Spring Boot, but in a more discoverable way with this kind of DSL. So here, for example, if I want to specify some logging, I can use this DSL to specify it like that. And this is declarative. This is declarative, so if you want to do some if, for, etc. statement, you can do it. You can retrieve some parameter, some value from the environment. You can get it from some configuration file. You are in control of doing what you want. You can also, so we are going to migrate that application in a Kofu mode. So we are going to remove the configuration. Block properties will remain, but we remove the annotation and we use the same configuration properties thing, but in a more declarative way like that. So we are going to declare block properties here, and we are going to leverage Kotlin name parameters to specify it like that. This is the same way, but again, that's something that is more declarative with this kind of API. We are going to add the, or we can maybe add the data configuration. So, an interesting thing in Kofu, I think, is that it allows you to define custom configuration slices. You may be aware of slices in Spring Boot tests when you have the web slice, when you have the data slice. That's kind of predefined configuration slices because of Spring Boot principle of auto-configuration. The spirit of Kofu is to allow you to define your own slices and to give you the control of what you enable and what you don't enable, useful, for example, for integration tests or things like that. So here, I'm going to define 3 size slices. The first one is the data config, where you see I specify only the relevant configuration part for the data, the persistence part. So I'm declaring the bin. So this bins DSL is something that is built in Spring Framework 5. Okay, so this feature is built in Spring Framework. We are just reusing it. And inside, I can declare bins using just a reference to the class. So here, that will automatically create the bin and auto-wire the constructor parameters by type. But if I want more control, I can also... It's really about defining your bins with supplier, with lambdas. So you can also create your instance like that, and you provide some custom parameters. Yeah, so you really you have full control on that. Here, I'm just declaring R2DBC PostgreSQL that will basically trigger the R2DBC PostgreSQL configuration. I'm declaring also a listener to be able to initialize my database. And since everything is explicit, I will enable this configuration in my main application. Now, we are going to migrate our annotation-based controllers to functional framework. So functional routing and functional handlers. Because Spring WebFlux and now Spring MVC are provided with an annotation-based programming model that you all know, at controller, at request mapping, but you can also now use them in a functional way with lambdas, and I'm going to show you. Be aware that as of Spring Framework 5.2, it is available for both WebFlux and WebMVC. So we now can use WebMVC in a functional way if you prefer this kind of model. So we are going to begin by turning these controllers into handlers. You see, controllers contain at the same time the mapping information and the handler implementation. Handler will only contain the handling part without annotation. So I'm going to add the article handler. So here I still inject my article repository, but in terms of implementation, I'm using the functional programming model, which basically just take a server request and return a suspending function and provide a suspending return value of type server response. Okay, and this API provides you various capabilities to do rendering, to specify the headers, etc. So this is the functional API that is again available for both WebFlux and WebMVC. And for WebFlux, it is available with reactive operators and with Coroutines extensions. Here, obviously, I will leverage the Coroutines extensions. I'm going to migrate in the same way the command controller to a command handler. Okay, let me just import extensions. So again, we just specify the handling part, the routing part will be in another place. And we do the same for our HTML controller, which is now an HTML handler. Okay, so now we have our three handlers. We are going to introduce the router. So the router is leveraging the other DSL that is provided with Spring Framework. In Spring Framework, there is currently two main DSL, the beans one and the router one. And here I'm just using Corouter, which is the Coroutines version of the router. And it provides you a programmatic way to define your routes. So you have, and I think consuming that on Kotlin side is much more readable and easier than on Java side, but it is also usable from Java. You basically define request predicates that can be combined. You can put condition request predicates based on the headers, etc. So you can also create your own request predicates. Okay. And then you map that with an handler. So you could directly write the handler like that. So you can directly write handler like that, and then you call server response dot okay dot specify the body, etc. Okay. Or in more in bigger application, you will just specify the handler using method references like that, and you can navigate to your handler. Okay. So here we split the handling part and the routing part. I have created a single router, but you can combine them, so you can create as many routers you want. It supports nested predicates, so it's quite powerful and composable way of defining your routes. And it's not just about specifying, it's not just a syntactic sugar. Again, this is programmatic, so you can basically create some for loop to define routes dynamically at startup or each time you receive a request. So basically you can maybe use that to develop e-commerce or of a CMS or a CMS solution that is leveraging information from your database, maybe a remote one because we are using Reactive API, while with the annotation programming model, everything is more static and less flexible. Now that we have defined this web server, this router, we are going to create our server configuration. So let's take a little bit some time to discuss what is there. We define the beans using a reference to the various handler. So here again, it will be the constructor parameter will be inject by type. In Spring Framework 5.2, I have added a new feature that allows to inject top-level functions, because Kotlin is a functional language that deals with top-level functions that are not tied to a specific class. And if you have followed my router is just a function, a top-level function. And with Spring Framework 5.2, I can use method reference to top-level function like that, and every parameter will be injected automatically, and it does not even use reflection. This is all done at compile time by Kotlin. So you can declare your router like that, and then you declare, because everything is explicit, you declare your web framework. And since this week there is support for WebMVC in addition to WebFlux, so if I would have chosen here servlet, I could use the WebMVC support. It is the early stage, but I want to demonstrate that it is not WebFlux specific. You can use both WebFlux or WebMVC stack. Here, for the sake of the demo, we are going to use WebFlux. When I say that things are explicit, I think every year on Spring Framework we have an issue raised by somebody that would like a different behavior between some interference between the string converter and the Jackson converter, and the wrong one is taken because by default we create that in a certain order. So here really the spirit is to give you the control. If you want to change the order, you change the order. You are in charge of declaring what you use. That means you will only get what you use. That will start faster. You will consume less memory. And also you will avoid some kind of misunderstanding of the default Spring configuration. And this is not just plain function. I mean, every kind of things like that, you have access to the configuration API that allow you to customize. So for example, every Spring Boot capabilities to customize Jackson is available here. If I want to enable pretty print, I just do that. It is discoverable. So again, no real need to have a look to the documentation. You can discover that from inside your IDE. Okay, so we have declared our codecs. We have declared prettyprint for Jackson. We have enabled the mustache, the mustache templating, and now I'm going to enable this configuration, and I'm going to create a last slice, which is the HTTP client slice, okay? But really, you can create as many slices with the granularity that you want. Okay, I think it should be fine. Maybe just a little thing to do is to use effectively app. So I'm going to do that like that. And I'm going also to migrate the test. So with Kofu, you don't need everything is explicit, so you don't need JUnit extensions to run your test. You will just so this is basically the same, close to the same implementation. But what you do here, the test that we have previously, I should have shown you, but it was mocked. Okay, mocked on the data side. So here, what I'm going to do is to create a custom application just for the sake of this test. I will only enable server config and client config because I don't want to get my database and all these things. And then I will mock. So mock with 2K is Kotlin equivalent of Mockito. Okay, so I will mock the article repository to provide some fake implementation. So here you see that you are in control of enabling what you want. So basically, with no more lines that regular Spring Boot with annotation, you are in control of what you declare and you know what is running. The last one is the integration test. So for the integration test, I'm going to just use the plain app that I have defined at the application level, and I will just run that. So let's see if that works. I did a lot of changes, so okay. And the website is ugly, so I won't show it. Yeah. Oh yeah, I can remove it. That's not used anymore because it is reference for. It is reference here. So indeed, I don't need anymore the annotation here. I don't have any more annotation here, and also, like I have shown, I don't have any more the add configuration annotation. Good point. So this is incubating. Initially, I created Jafu, which was a Java alternative of that, but I have decided recently to stop that effort because it was just too much noise in terms of code, and I think that will stay niche. So really, I think it's not doable in Java, at least with Java in its current stage. Maybe later, if Java do more progress to provide more compelling features, maybe that will also be usable in Java. But right now, I just can't find a way to make that usable in a readable way in Java. So currently, the idea is to focus on Kofu side and collaborate with Spring Boot team to make Spring Boot providing a kind of programmatic API. It's really incubating, so no promise it will be supported first class. That's really my goal, and I will work hard for that, and I will try to convince Spring Boot team and others. So feel free to start the project if you are interested by this approach. Every support from the community may help to get that supported first class, maybe in Spring Boot later. And a last point about the status. So what is production ready with Spring Boot 2.2 is WebFlux. And another super interesting topic I have not the time to talk about is AirSocket. And I also provide coroutine support for AirSocket. So you can use @message mapping and AirSocket requester with coroutine extensions. Coroutines support is provided in Spring Data, Reactive, MongoDB, Redis, Cassandra, and R2DBC when it will be GA. What is work in progress is the Coroutines repositories. So basically the idea is like you have the Reactive CRUD repository, you could have a Coroutines CRUD repository that you could extend with suspending methods, etc. to follow the usual Spring Data pattern. We are working very hard, and all the Spring Data team is doing an amazing job on that, on R2DBC and Spring Data R2DBC to make it reach the 1.0 GA point. And Kofu, configuration for Spring Boot, is incubating on Spring Foo side. And yeah, it's moving pretty fast this day. And feel free to test it, bring feedback. We have, for example, somebody from the community which is currently contributing a Spring Security DSL. So a Spring Security Kotlin DSL that will allow you to configure with this kind of declarative model with a full Kotlin DSL Spring Security. And I think it's a very good use case for that. So feel free to help. I mean, thank you for your attention. I have added 3 links. The link to start.spring.io that give you access to this page to create new Spring Boot project with Kotlin preselected. A useful link. The link to the tutorial that you may follow if you want to learn how to develop a Spring Boot application with Kotlin and GPA. And the last link is very long, but it's a blog post about Coroutines and Kotlin Flow support, where you can find more detail. I know I have presented a lot of stuff today, so yeah, you may need the time to read that quickly. Thanks.